We're going to talk now about a little different item from what we have been talking about. And the idea is, instead of slopes and derivatives, we're going to be talking about areas a little more in the coming days. So on the handout there, got a function, y equals f of x. And what I want us to do on the first one there is estimate the area under the curve. And notice I quote unquoted that because there's a little more to it than necessarily under, but for now we'll go with under. Estimate the area under the curve from x equals 0 to x equals 9. And on number one, we're going to use 3 rectangles. Okay, so estimate the area under the curve. All right, so again, there's more to that word. When we say under the curve, here's what we mean in this situation. Then there's some other little twist to it later, but when I say under the curve, what I mean is between the curve and the x-axis. Under is just a nicer, quicker way of saying that, but really what we mean that is between the curve and the x-axis. The x-axis either side, but that's what under the curve we really mean by that. So we're talking about, I've got 2's here, I did mine by 2's, so I think the handout's got them in 1's, but so I'm going from x equals 0 out here to x equals 9. So I'm going to estimate that area under that curve, because yeah, it's not any kind of shape that we would know a formula for, because it's got a curve to it like that. You know, we like the nice straight line polygons and things like that, but yeah, we've got this curved edge, so that's what makes this go into an estimate here. Now I am going to use rectangles, and then for number 1 here, I'm going to use 3 rectangles. They're going to have equal width. The heights are going to be different, but they're going to have equal width. And then we have to, here's the other thing we have to decide is how are we going to get that height? Well, we're going to use right-hand endpoints in this first one, okay? Right-hand endpoints. So to estimate this, all right, so I want equal width. And so since I'm going from 0, mark off the intermediate ones there, 0 to 9, that's 9 units. And so the equal width there is 3, of course. So I'm going to come at 3. And by what I mean by right-hand endpoints is that's going to determine the height, because I'm going to go to my right-hand endpoint from 0 to 3. I'm going to go at the right-hand endpoint and go up to the curve, and that's going to determine my height. So this endpoint, that's going to give your height to your rectangle. That determines the height, or the width, or whatever it is you want to call it. So this first rectangle, okay, so I got a 3, and then the height, let me get it on paper so it's more precise. What did you say, about 1.5 here would be where it hits the the y-axis. It's about 1.5, so our area is approximately equal to, this first one is a 3 times a 1.5 rectangle. So that's the area of that. All right, then the next one, same width, 3 to 6, but the height's going to be different, right? Because I'm going up at the right-hand endpoint there, which at 6, it's about, let's call it 3 3.2 or something like that. Where would you be okay with that? 3 1/4 or something like that. It's not quite 3 1/2 by my observation here. And then the last one is, of course, 3 again is the width, but the height, I'm going to go up at the 9, and I think that one's actually the easiest one of all. It's at, the height would be 6. Come over across there, 3 times 6. So those are the area of those rectangles. Now, is that a good estimate? I probably wouldn't call it a good estimate of that area under the curve, but it is an estimate. And we can get some better ones along the way here, but that's our first one. What is that? 4 1/2, 9.6, and 18. So that's whatever that is. 22.5. Is that 42.1? About 42.1. If I added those right. Yeah. Yeah, because that's 14.1. Yeah. Wait. 32.1. Somebody help me out. 32.1. That's right. That's right. Okay, 32. Okay, so yeah, that's clearly not the area under the curve, but it gives an estimate of something we know about. We know about rectangles. We know about the areas of rectangles. So it gives us a start anyway to estimate this area. But obviously, it would be an overestimate because the rectangles have a lot more area there than we need. Okay, so let's go to number 2 here. Same curve. And let's estimate, so that was number 1, right-hand endpoints. So number 2 here, let's use left-hand endpoints. So same thing, 3 rectangles, 0 to 9, 3 rectangles of equal width. But in number 2, we're going to use left-hand endpoints. All right, so here's 9, 0. So it's still 3 rectangles, so I'm still looking at 3, 6, 9 divisions on the x-axis. But I'm going to use the left-hand endpoints, and so instead of going up at the 3, I'm going to go up at the 0, the one on the left here. And so that's going to give me a different height for that first, well, for all the rectangles, but for the first one, it's a little bit smaller rectangle. And at 1, at 0, that height is 1. So our area in this case under the curve, 0 to 9, the first one is a 1 by 3 rectangle. So let's do 3 times 1. Then the second one is the 3 to 6, but I'm using the left-hand endpoint, so it would go here, which I believe that one was, we called it 1 1/2 height there. So that's a 3 times 1 1/2. And then the third one, we go at the left endpoint, so it goes up to 6, which I believe at the 6 I called it 3.2. Use that again. And so there we get an approximation of 3, 4 1/2, and the 9.6. Was that 17.1? I believe. 17.1? Does that sound right? About. Okay. Now, what we can say about that is that an overestimate? Well, no, because now these rectangles that I've drawn in, they're not quite enough, are they? The true area has a little more to it than those 3 rectangles. So this is an underestimate. So one thing we could say about it, the true area it's somewhere between 32.1 and 17.1. It's somewhere in between that. And I guess we could average those out and do something like that. But here's another thing we could do. All right, so we did right-hand endpoints, left-hand endpoints, but we can also do, so on the third one here, let's do midpoints. Use midpoints instead of left or right hand endpoints. Let's use midpoints. So it's still 3 rectangles, 0 to 9, still 3 rectangles. So I'm still dividing this up, if you will, into 3, 6, and 9. However, to get my height, I'm going to use midpoints instead of the left or right endpoints. And so, yeah, I've got a, so this area is approximately, you know, the width is still 3, but then the height, well, I don't go up the endpoint, I go up the midpoint, which the midpoint here would be, it'd be at 1.5, and so I would get the height there at 1.5, which, what would you say that is? Oh, it's just above 1, let's say 1.1. I mean, these are estimates, so if you guess a little something different than mine, that's fine. But I'm going to say that's 1.1 at 1.5, that's the height. All right, so then 3 to 6, well, I would go at the midpoint, which that would be at the 4.5 x value, so go up to that. It's still got a width of 3, but now the height at 4.5, well, I'm going to say at 4.5 we are at 2.5, 2.5. Does that sound reasonable? 2.5? So that rectangle is 3 by 2.5. And then last but not least, go in the midpoint for 6 and 9, which is 7.5. So go up there to get the height. And what do we have in that particular case? 7.5. Let's just call it 4.5. That's what it looks like on mine. Okay, so that area is approximated that way is 3.3, 7.5, and 13.5. Right? I think so. It's 21, 24.3. Now, the good thing about the midpoint is this is an even better estimate than those other two, because notice on each rectangle you got some give and take, don't you? Because you got part of the rectangle is over, but then part of it is under. So it kind of balances itself out. Now it doesn't totally balance out because, you know, those aren't exactly the same all the way around, but you get the idea. Yeah, your midpoints are usually going to give you the better estimate out of these three options, but anyway, that's what we're going to do. A couple of these, how we're going to estimate these areas. Now, of course, to get an even better estimate than even these three, even with the midpoints, we could do more rectangles, because the more rectangles you have, the bigger, the smaller the gaps, if you will, that you'll have on these things for any of the three. So more rectangles is better. So, you know, there's a limit to how many we'd want to do, of course, and we'll get to some different ideas where we're going to have to actually draw these rectangles in. But this is how we begin starting anyway. All right, now let's talk about a couple of other things. There are some notations here. So let's use these on this fourth one on that handout. Let's change it for the fourth one. Let's estimate, number 4, estimate the area under the curve from x equals 1 to x equals 8 using and I'll just introduce some notation here to you. R5. This is just kind of a shorthand notation that'll help us. Instead of saying 5 rectangles with right-hand endpoints, we can use a little notation here, call it R5. Yeah, R is for right-hand endpoints. So this is right-hand endpoints, and it's 5 rectangles. So it's a nice little notation. This would be over here then. This would be M midpoints and 3 rectangles, so that would be M3 for that particular area. So that's the first thing. Now, the other thing is these are all equal width, and the width is usually given a name. It's because it's basically the width is the change in the x's. It's called the delta x. And so that's another notation. The width of these rectangles is going to be, we'll call that the delta x. And so delta x here was a 3. Each one of them had that in it. But now, the other thing is there's, I changed it up from x equals 1 to x equals 8 now. So it's up here like that. Okay. And so what is the width going to be here? Well, I mean, you might can figure it out just by looking there, but there is a formula. What it is, the width is going to be, if you think about it, the width came in because on this one I had 9 units to cover and I wanted 3 rectangles. That's why delta x was 3. I had 9 units and I wanted 3 rectangles. Well, here I've got 7 units between them. And so we put this in a formula. If I subtract the 2 x endpoints, that'll tell me how many units to cover, 7 in this case. And then I want to divide it into 5 rectangles. And so if I divide that by 5, 7/5, so that's 1.2 in this particular case. Sorry, 1.4. Round, expect it to a decimal there. So this delta x, there's a formula involved. It's you take the 2 endpoints, which we're going to refer to as A and B. That'll be our general notation for those 2 endpoints. What I'm trying to find the area, the x values, the endpoints there. The first one is A, and the second one's B. So a lot of notation, but it's the same for all these. So the delta x formula turns out you do B minus A, and then you divide by the number of rectangles. Well, the number of rectangles, we're going to denote that with the letter N. So quite a bit of little notation, but once you know what they are, it's not that bad. Okay, but that formula will stay consistent throughout our discussions here. That's what delta x is. That delta x, the width, is that's always going to be the formula. Okay, so what does that mean for us here? All right, so my width, it won't always be a whole number. Sometimes they'll throw some decimal at us, but so in this case, I'd go for the first one. I'd go out to 2.4 And I'm using right-hand endpoint, so I'll just go up at 2.4. And so my area here is going to be approximately, well, it's 1.4 times that height going up at 2.4. So I'm going to say that's 2.4. We'll just call it 1.5. Like I said, yours could be slightly off from that. That's okay. Close counts on these. All right, then the second one. All right, so then I would go another 1.4 from that. So that would put me where? 1.4 plus that 3.8. So I go the next one, go up at 3.8. And that would be the height for that one, which 3.8 is not quite 4, but I'm going to say that's right at the 2 value there. So forth and so on. All right, so then I'd keep that going. 1.8 plus that would be at 5.2, wouldn't it? So go up there, that would give me the height, 5.2. I'm going to say that's 2.8. So the width is 1.4, but the height is 2.8. Then the next one, add 1.4 to that, 6.6. 6.6 to that, so 6.6. I'm going to say that height is, let's just call it 3.6, or something in that ballpark. And then the last one is, of course, 1.4 to that would be at 8. So I just go up at 8, which at 8 it is, it looks like it's right on 5. We'll call it 5. Yeah. Now, one thing, we can multiply those together, that's fine, but one thing you might note here is that the 1.4 is in all these, and so here's another, if you want to, you can factor off that 1.4 and just add up the heights there. So just an FYI if you wanted to. That's another, instead of having to multiply each time, pull off the 1.4 and multiply it one time by the sum there. So just another, you don't have to do it that way. But, makes it a little quicker if you want to do it that way, but not that much. So that's up to you. I get 20.86. So somewhere in that vicinity would be the approximation for that area. Okay. All right. Back to our first three. You know, we were doing 0 to 9, 3 rectangles and midpoint. It turns out the true area of this was 24. The true area is 24, so that midpoint did a pretty good job. The true area under the curve is 24. It gave me 24.3, so, or mine did. But we'll talk about how we can get that exact area in the coming days. But just FYI on that one, I don't know what the true area on that one was. I didn't figure that out, but I did want to make note of that. Okay, all right, so here's kind of in general what we're doing. So we've got this function, and you know, it can be any shape or size. We'll work with functions that are curvy and some that may not be that curvy, some more curvy than others. But when I'm talking about the area under the curve, and again, using right-hand endpoints and, well, or left-hand endpoints, doesn't really matter. Well, I guess if I draw them up here, like I'm going to, we will use right-hand endpoints. So, like I said, the far left endpoint, we're going between, from left to right, the X endpoints, the far left one is A, the far right one is B. I already mentioned that. And so, depending on how many rectangles I want, in rectangles, well, another way we can think of that, here's another term for you, is what I'm doing with these n rectangles is I'm subdividing the x-axis into n pieces. And so another way we can say this is we want n subintervals. And so that would be another term you might hear. That's again just telling you, it basically tells you the number of rectangles, but subintervals, you're dividing the x-axis into that many pieces. That's what it means. All right? Now, okay, so let's, way we can denote that is, let's just choose a width. And our width then is delta x, b minus a over n. That'll determine the width of these subintervals. We've already mentioned that. Now here's another little notation. Okay, so I'm doing this in general, so I don't have numbers I can plug in. You know, that one was 1, 2.4, and then 2.8 were the endpoints of the subintervals. So what do we do in general? Well, what they do is they call them x sub i's. And so this first one we would call the first endpoint of the first subinterval, the right-hand endpoint, we would call that x sub 1. And then the next one over would be x sub 2. And then the next one over would be x sub 3. So those are, again, just kind of notation. And so you keep those going until you get to the n one, which the very last one is b, of course. And b, if we wrote that in the x sub I notation, would be x sub n. Like over here, the 2.4 was x sub 1, the 3.8 was x sub 2, the 5.2 was x sub 3, the 6.6 was x.4. Well, the b here, the 8, the last, the endpoint of the area that I'm going under there, that's x sub 5, right? So that's what we're saying. The very last one is whatever your n is, it's x sub that, whatever that number is, okay? Now the other thing is, if we back up, what would that make a? If that's x sub 1, that's x sub 2, wouldn't a have to be x sub 0? So it's a lot of notation, but like I said, once you get used to it, it sort of makes sense. Okay, now, if I'm using right-hand endpoints, let's talk about the heights for the notation. So I'm using right-hand endpoints on this one, so I would go up for my height, I would go up at x1, right? X sub 1. And then the height at x2 would be, I would go up, the height of the second one, I'd go up at x2. So how can I represent those heights? What are those heights? Because I don't have a curve and I don't have numbers I can just put on those. So what would I do for the heights? Well, and this is what we're going to do in the next example. We can actually use the function here, can't we? Because isn't that height there just whatever the function value is at x1? So this first height is the function value at x1. It's whatever the y value is at x1, but put it in another way, it's the function value at x1. You with me there? That'd be the first height. Then the second height would be the function value at x2. And so on and so forth. Function value at x3. So these heights, they're actually function values. Okay? If you, and you know, they match the right-hand endpoint here. Now, of course, if we use left-hand endpoints, it'll be a different function value at each one, but with right-hand endpoints, it's just the function value at whatever particular endpoint you're at. So I know it's a lot kind of to take in at first, but it gets a little more easy to understand because we'll keep this same